All right, I'd like to call this meeting, the Green Ribbon Science Panel, back to order. And we will be starting our discussion on the carpets with PFAS proposal. So the department has some specific questions for the science panel. And before we turn to Andre's presentation, I just want to note to make sure that those who are not in the room realize that there were comments received this morning with regards to this item, and the panelists received a hard copy of a letter, April 16th letter from the Fluoro Council, so had a chance to take a brief look at that. Yes.
That letter, I believe it's the same letter that was received during the public comment period, and it's available to anyone if they would like to see that letter on our CalSafer site under the comment period related to carpets with PFAS.
All right. So with that, I'm very pleased to welcome Andre's presentation, and he'll be giving a brief overview on the scientific rationale behind DTSC's decision to list carpets with the entire PFAS class as a priority product.
Thank you, Kelly, and I'm going to point this. I think it's directional because I'm pretty far from it. So thank you, Kelly, and thanks for your attention today. Good morning. I'd like to start by giving you a little bit of overview of what we're doing and why we've decided to take an approach of naming an entire class or including an entire class of chemicals in this proposed product chemical combination. Then just a very brief overview of some of the major categories of PFASs and how they sort of fit into the picture. And then a little more discussion of the rationale for the class approach. So I guess the initial comments I wanted to make are just sort of the basis for our concern, and then a little bit more about our rationale. So I think it's this button. We began talking about PFASs in carpets and rugs in November of 2016 when we had what we called our mega webinar. So we kind of rolled out several topic areas that we were interested in exploring for potential priority products. And we then took back some of the input that we received at that public workshop, and over the next year developed a product chemical profile, which we released in February. And that profile lays out the scientific and regulatory basis for adding carpets and rugs containing any member of the PFAS class to our list of priority products. So at a previous GRSP meeting, it might have been around the time of that mega webinar, we had, I think it might have been from Dr. Schwarzman, we heard some suggestion about incorporating conceptual exposure models into our documents, and so we've really taken that to heart, and we have some talented graphic design folks that helped us with this. So the main sort of general thing about this picture is that there are multiple routes by which PFAS members present in carpets and rugs can expose people or biota to these chemicals, either directly through sort of indoor exposure from air and dust, for example, or when wastewater is discharged and enters wastewater treatment plants where it can partition into various compartments, and then also at end of life when carpets are landfilled or in some cases incinerated. So the main point is that in this box, because PFASs are very persistent, they don't they break down to a certain extent to other PFASs, and then they persist. So as PFASs continue to be used and released from carpets and rugs, they continue to accumulate, and it's a kind of a closed cycle. There's really not natural degradation routes to get rid of these once they're created. Oh, that's the laser. This is what I want. So we can group PFASs into four categories: the perfluoroalkyl acids, the precursors, PFAA precursors, fluoropolymers, and perfluoropolyethers. And so I'm going to go briefly through each of those. So the perfluoroalkyl acids include the perfluorooctanoic acid, PFOA, other carboxylic acids, sulfonic acids like PFOS. There's This is the category of PFASs for which there's the most data on toxicity, on environmental fate, things like that. These aren't what are used to treat carpets and rugs, but they are used to synthesize the treatments that are used in carpets and rugs. And they can be present as manufacturing impurities or degradations if the side chains cleave off. And to the comments that were read earlier, this would include both the longer and shorter chain PFAAs like PFOA as well as the PFHXA and PFHXS that might be used in domestically manufactured carpets nowadays. So then we get to the PFAA precursors, and this group includes the side chain fluorinated polymers, which are the treatments that are most commonly used to impart stain, soil, water, and grease resistance, things like that, to carpets and rugs. So these can be environmentally persistent. It also includes, for example, the fluorotelomere alcohols. So these chemicals can be environmentally persistent and mobile in the environment, and some of them are very acutely toxic. So this is kind of a pretty large kind of a catch-all category. And then finally, we've kind of grouped on this slide the perfluoropolyethers and the fluoropolymers. These typically don't degrade. They don't. They aren't, to our knowledge, currently used to treat carpets and rugs. However, they could be, as evidenced by a patent that was filed in 2013 by Invista, I believe, that cites fluoropolymers and perfluoropolyethers as potentially suitable treatments for carpets and rugs for stain and water repellency. So these are extremely persistent again. So I guess let me stay on this slide for a minute. So the basis for our inclusion of the entire class of PFASs is that we have concerns about all of them because of their persistence. That's kind of the unique property that they all share, the property that's common to all of them. Because of the strength of the carbon-fluorine bond, they are indefinitely persistent in the environment and in biota and in people when we're exposed. Well, they do have long half-lives. Let me rephrase in people. And the half-lives vary, but they're all environmentally persistent, and that in and of itself is a hazard trait in our framework regulations. Our profile and the summary that's included in your packet references the environmental hazard trait of persistence, and that is in the OEHA regulations that sort of spell out what the hazard traits are. So we follow that framework in identifying the hazard traits of candidate chemicals. So we have concerns about the whole class. We would like the responsible entities to look outside the PFAS class for potential alternatives. So obviously some of these chemicals are better characterized than others. Depending on the source, I've read there are 3,000, 4,000, or 5,000 unique CAS numbers for members of this class, and new ones are being synthesized. So we can't know all of the PFASs that are or might be used in the future in carpets and rugs. We have kind of, in going forward in our subsequent drafts of this document, we have made a clarification that we aren't asserting that many or most or all of these chemicals are currently used in carpets and rugs. So we're kind of flipping. I was about to say flipping it around, and I flipped the microphone. So we're kind of flipping the order in which we describe the product chemical combination, and we're saying carpets and rugs with PFASs rather than PFASs in carpets and rugs. It seems like a small change, but we wanted to acknowledge that the way we had worded it in the draft that we released back in February could be confusing. Wasn't our intention to imply that things that aren't used in carpets and rugs currently are used, so we're hopeful that that will help. And we've also added some clarification in the product chemical profile. So, we've had to rely on the data that we have. There's a tabulation in the appendix to the profile, and appendix 2. It's not in your packet, but it's in the full product chemical profile that sort of tabulates and summarizes some of the hazard traits. There is actually a summary of the hazard traits as well in the document, a short table of human and ecological hazard traits. So, we don't have full data on all of them. There's really potentially an infinite number of permutations of PFASs. We really just are using the data we have and the fact that they're all persistent and the fact that we would like the responsible entities to look outside of the class for potential alternatives as our sort of rationale for doing this. So we had some questions that we would like you to weigh in on about this approach that we're taking. Number one is we would like to know how effective you think we've been in our documents in communicating the need for a class approach in this product-chemical combination. Do you have any questions about the rationale and the underlying science that we have cited? Secondly, how do you think this approach fits in with the SCP program, the green chemistry law, and our regulatory framework? Thirdly, the fact that we don't have the same level of data for all members of the class, how does that affect our case? How is it significant in our proposal? And finally, how would we potentially apply what we're learning in our current class approach to future product chemical combinations that we might look at? So let's see if I had any other small points I wanted to make. So I think that's kind of my summary. It's more detail in the packet, and we'd just love to hear what your thoughts are about this proposal. So I'm going to just open it up to questions and discussion. Thank you.
Thank you very much, Andre. This is very helpful, and so was the information in the packet, the profile in particular, and the supplemental references. I see Dr. Williams would like to say a few words before we move on.
Just a word about process, because it can be a little confusing how we get from a proposal to an actual listing. And we had a public comment period on the initial draft of the product chemical profile, and we then take the comments that we received, and then as applicable, we revise the document and add additional references, do whatever else we think we need to do to really finalize that document. That document needs to undergo the state's external scientific peer review process, and that process is focused on getting people with the right technical expertise to weigh in on whether or not we've met our regulatory criteria based on the science that we've used for the decision. And so we are finalizing that document in anticipation of that peer review process, and then we would revise the document again or respond to any comments we receive in the peer review process, and that would become the basis for the priority product listing and the rulemaking.
So just to be clear, the purpose of our discussion is to help department with the lessons learned here. So how does the science panel, many of you were on the original panel, and one of the recommendations of the panel that the department decided to include in the regs was the ability to capture a group of a family of chemicals when it was doing a listing. So this is the first example of that, and the department's asking us these questions around that as a process. What's to be learned here from this example? So what can we do going forward? So we don't have to provide the expert peer review here, but we should be giving the department feedback on how they're approaching this. So we're going to start with just informational and clarifying questions and move very quickly into the panel responses to these comments. So if your question goes into comment, maybe you want to hold it for the comment part. And I want to kick off the informational and clarifying questions just with a clarification. We heard this morning in the industry comments that I just want to make sure I correctly understand that, Andre, you said that not all of the chemicals, in fact, only a small subset of the chemicals in this family are actually deliberately applied in carpets today. And so and I think you showed the group that a subset of which are actually deliberately used in carpets in your second slide. Is that correct?
Right. Typically it's really the vast majority are side chain fluorinated polymers, and historically the side chains tended to be 8 carbon side chains, and that's what the commenter was referring to. The domestic manufacturers have made a transition entirely, and I think all of the domestic carpet manufacturers have switched to a shorter side chain, and the shorter side chains have a shorter half-life in the human body than the 8 carbon side chains. So that's part of their basis for making that change. However, carpets that are available in the market from that are imported may still include longer side chains.
And then I think you also mentioned that during the manufacturing process and then afterwards in environmental degradation, that some of the other chemicals, particularly those on the first slide, would occur as a consequence of the use of the chemicals that are deliberately applied, so either as impurities or degradants. Right.
The backbone of the polymer has the 6 or 8 carbon side chains attached. Those can cleave off as well. They could still be present as the individual PFAAs, potentially as residual PFAAs.
Thanks. I just wanted to clarify that because that had kind of stuck out as a major thing. So other just brief informational clarifying questions, and then we'll move into comments. I see Helen.
Yeah, just another sort of parallel idea to that is just clarifying that the concern is persistence, and that that's the driving factor for this as a class, is on the persistence primarily.
That's something you can say about the entire class, is that extreme persistent characterizes this class. So there are some other concerns about the PFAAs that are summarized in the document. But yeah, if we're talking generally about the class, persistence is the big one.
So you're not saying that they have all the same level of toxicity?
No, they don't. They don't. And a lot of the toxicity of many of them has never been characterized.
Seeing no requests for informational or clarifying questions, we'll move on to the questions the department has for the panel. And I'm looking for comments on that. So Dr. Sutton, Dr. Geiser, Dr. Schwarzman.
Hey, just wanted to express extreme strong support for this class-based approach. I think it's great for avoiding regrettable substitution, and definite strong support for considering the entire PFAS class as a class, now 5,000 plus members according to the US EPA master list. So the persistence is, good throughout the class, right? They're all chemically extremely persistent. I wanted to point out an interesting thing in the toxicology that you guys provided that I thought was a really strong insight in terms of the PFAAs that you mentioned are more well-studied and have a lot of very specific concerning elements for human health, also for wildlife health, which is what I'm more in charge of in my studies. I thought it was really interesting how you guys pointed out that because you're focusing on how these chemicals are used in products and how you have this life cycle thinking approach, that the toxic properties of the PFAAs are also relevant to the greater class, because the PFAAs can be feedstocks, they can be terminal degradates, they can be impurities. So we can't just say a less well-studied compound doesn't have some inherent toxicity because it may have these chemicals as an impurity, or it may degrade to these chemicals, et cetera. So this is a really important element of this approach that incorporates both the use in products and that life cycle thinking to get us to think a little broader about how these chemicals are made, used, and how they get out into us or into the environment where I jump in. So I just wanted to also mention that from my perspective, I work with the San Francisco-based Regional Monitoring Program. We also consider these as a class, and just wanted to, for a visual. So this is the profile, pretty hefty. And this is our recent PFAS synthesis and strategy of all our data in the Bay. Similar, these are these are chemicals you really have to have a lot of expertise to study. We study both the PFAS and some of the the other elements of the class, and we have a lot of concern about them. We consult with leading experts on this field, and they also strongly and publicly support the class-based approach and think because of the persistence, the global distribution, and potentials for additive or synergistic effects for some of these understudied or completely unstudied compounds, they're all telling us to keep considering these as a class. So I just wanted to bring all that, those comments from my work groups and my meetings into this meeting as well.
Thank you, Becky. I've got Ken, Meg, Mark, and Art.
So I'm just going to build off of what Becky just said. You asked the question, is the presentation support the class-based approach? And I want to be clear, I also am excited about a class-based approach, and I think this is really important work of the future, and also it's a great test of the Safer Consumer Products reg at the moment. So I really like going this direction. And the answer to the question is no. I don't think you've built that case. I mean, when you stood there, you just, and I don't mean to say you, I mean, but I was looking for it in here, and you said, well, the basis for the class is the persistence, and then the second basis was we would like to get people to look outside of the entire class. Those were the two arguments that I thought you made. There was a sub-argument kind of around, well, these things have a dynamic, a life cycle that they both degrade into other things, so that's in the class, and they come from some of the other things in the class. So there's another argument, not just that they're persistent, but they have a relationship over a life cycle in which they are morphing into other members of the class. Now, you added another thing I thought you were starting to add around, and they're all internationally ubiquitous as pollutants. So that's a possible another one. But I still don't find in all of that a real thing to hang on yet in terms of, I mean, you already have said you haven't said wide, but you said diverse, and I'll leave that. Diversity in toxicity, diversity in whether they're used in rugs, diversity in the amount of science. In other words, there's some real arguments for why it's not you can't make a class out of it. So I'm with you, but I don't think it's got there yet.
Okay.
Meg, Mark, Art, Mike.
Thanks, Ken. You just set me up so well. I also want to echo what Becky said about just real support. I think for the scientific basis of addressing PFASs as a class is there, and I think it's supremely consistent with the goals of the SCP program, which set out to do exactly this, which was to provide a mechanism for avoiding the switch to a close-by chemical that isn't under regulatory scrutiny. So I think it's highly consistent with the goals of the regulations and of the SCP program. So, but then the question that you're asking us is, and that Ken was getting at also, is does this make the case for it? And I think there's a couple of things that I would add that you've kind of hinted at, but that aren't in the document. And one is the flip side of this diversity of toxicological data and applications is that it means there are poorly characterized chemicals within the class, and what the industry has, the pattern that we've seen in industry outside of PFASs is that there's this incentive to switch to poorly studied chemicals because they're not under regulatory scrutiny. So simply highlighting that diversity, it's not arguing that they be excluded from the class. It's saying, the point was to remove the incentive to switch to poorly studied chemicals. And so this class approach does that. Is one thing. being used in the industry fairly widely, and I think you're already aware of them. It's the structural, it's, what is the cross-section of the polymer fiber that's extruded, and how can that be changed to confer stain resistance on carpets, right? So you already know this. There are brands that are using that already extensively. And so in my recollection, that's one of the criteria that SCP can use. That the program can use in choosing a priority product and in making the case for a priority product is the existence of known alternatives. So you might just articulate that. I don't know what the sensitivities are around calling out a successful alternative that doesn't use the chemical. But anyway, I just raised that and defer to your judgment about it, but I wondered about the inclusion of that. The final point that I wanted to weigh in on is just to echo what I think Becky and both Ken and Becky said about, there's some red herrings in that letter from the Industry Council that have to do with narrowing the focus to, use phase of a polymer. And you, in your document, very clearly expressed the life cycle considerations, and that's a requirement under the regulations. So I don't think it's disputable, and maybe there is more that you could do to sort of highlight that to help address those concerns. But, we're concerned about almost no polymer in its polymeric form for obvious reasons. It's always about the monomer, the additives, the impurities, the degradation products. Maybe not degradation as much for these polymers, but some degrade to the monomer, and sort of have polymer bloom that produces the monomer again. Maybe not as much for this one. But in any case, all the others are true, and you've articulated that, but I think it's clearly something that bears kind of underscoring. I think that's all.
I'm going to let Dr. Williams step in here for a moment.
So we provided the panel with an abbreviated version of the overall profile. It was essentially excerpted key parts that related to the class concept, and we didn't inundate you with the entire profile. I see that. Okay, so I would mention that some of the alternatives are discussed in that profile, and some of the other things, but we appreciate the input anyway.
Including the Duratec, the non-PFAS fiber that you were, I think, referencing.
I've got Mark, Art, looks like Mike stepped back, and Jack.
I had a question, I guess, and an answer to the question, if I understand the question is the answer. Within the framework of the DTSC regulations, is there the sort of rebuttable presumption option where, I'm the manufacturer and I can say, well, I can prove that chemical X that I'm using in this product is just fine and dandy, and doesn't really pose any sort of extraordinary hazards and risks and meets all your criteria for what would be acceptable. I mean, is there that sort of provision?
I think that's the alternatives analysis in which, I think, that's where they would show their work. If the existing chemical or class came out favorably in a well-conducted AA, then they will have done that.
Well, it probably wouldn't come out for the whole class because the manufacturer isn't using the whole class of chemicals, right? They're using one or two. So, I mean, that's the question. And I guess then my opinion is that it seems to me that part of the argument that I heard was that the department hadn't shown enough information that something was harmful. And I find that to be specious reasoning when you're dealing with 3,000 or 4,000 chemicals. And I think that the burden would be on some affirmative evidence provided by the manufacturer, which would actually be data showing that it's okay, as opposed to the argument that, well, you haven't shown that it's bad. I mean, that's sort of my view of it.
Yep.
Thank you, Mark, Art, and then Jack.
Thank you. I also share Ken's excitement and concerns over this class-based approach. Actually, it's kind of sad when I get excited about that. And my concern is actually also goes to the fact that, given the fact that this is the first kind of pilot of this class-based approach, I think it's really important that you can come up with a defensible rationale for why you're doing this. And so perhaps as a suggestion, you can look at what has been done with the brominated flame retardants and how they basically come up with a rationale for grouping that as a class when it comes to regulation and finding safer alternatives or replacements. Because I think at this point, there's no argument that brominated flame retardants should be regulated or, treated as a class. So perhaps if DTSC hasn't done that, that's something that they can do.
Thank you very much, Art. Jack?
So in answering some of the questions, were they effective in communicating the need? I think, Andre, your presentation to me really said the class should be anything with a carbon-fluorine bond that's used in carpets. And so I think the way you communicated it could use some modification, because you said that was the primary basis for the class determination, was carbon and fluorine chemistry. And I think that brings up some issues in going to potentially other classes, polymers in general, carbon-carbon bonds. Could that be a class? Because they're not going to biodegrade very readily, and therefore it could be subject to SCP requirements. We're going to have plastic bottles undergo an alternative assessment. So I think we've got to be really careful in presenting the rationale for any class approach that you want to use.
They have to be on the candidate chemical.
They have to be on a candidate chemical list, but that list can vary. You've got 23, I don't know how many lists that you look at. So I think, again, you've got to be really careful in delineating the reasons for it, because really your reason was it's a carbon-fluorine bond. It lasts forever. And so I think that, again, the language you have to be really careful about that in terms of how you present it to the public. So, yeah, I think in this case, there is a potential for a class, but again, just saying it's because of a carbon-fluorine bond, I think you've got to watch out for that kind of rationale.
Thank you very much, Jack. Anne, and then Helen.
Thank you. I just wanted to add, having gone through a lot of the literature recently for an application of this class in a different consumer product category, I am also very excited about the class approach. And Jack, thanks for your comments, but I think Andre actually, I respectfully disagree. I think Andre did a good job saying the carbon-fluorine bond is what contributes to the persistence, and that's why we want to look at this as a class. So, but fair point. Your points are well taken. That we can quibble about the language and the chemical. Talking about the chemicals as a class. So I did want to acknowledge that scientifically, obviously there is going to be variability among classes, and that has to be acknowledged, but I think in this case you've got a very strong argument that the chemical characteristic is what creates the concern, particularly the environmental persistence, as Becky knows infinitely better than I do and has expressed beautifully. So, and again, I would also just like to echo that some of the comments that have been made about how this fits into the rationale of the SCP and the green chemistry law. So the chemical by chemical approach is simply not working, has not been working, and so we have to do this with the appropriate cautions that we've discussed. And the goal of the SCP was to avoid regrettable substitutions, as Meg referred to, within the same classes of chemicals and going to the same kind of chemistry, because that's how we train chemists. We go to the similar performance function and don't think about the toxicity. So I think this is pointing in absolutely at the right direction. So I think with that, I will, who's next? Helen.
Thank you, Anne. Helen?
So I want to return to the point that Jack was making and talk about building the case around persistence alone. This is something we struggled with a lot in the past for inorganic recalcitrant flame retardants and other things. And on the one hand, it takes toxicity off the table as an argument for the class, but it introduces other problems because there are other benign recalcitrant things in the world that aren't going to degrade. And so making that sort of the precedent that it's okay to have non-toxic things that don't degrade, and that's within scope, I think is a weak argument and shouldn't actually be the argument. I think that the better arguments are around that regrettable substitution, the chemical similarity, moving from moving a bond here to there, and all of a sudden you have a different CAS number, so you get that. I think that's a much stronger argument, but just building this strictly around persistence is weak and not actually healthy for the future cases you're going to have to deal with, because you really are going to have to deal with a range of toxicity. So imagining a different case, you might have some basically not particularly toxic things in that category, and you're going to potentially be restricting the use of those things if you take this approach. So you have to think about that really carefully. Is that something you want to open the door to, that we're going to use something that is known to be more toxic because something is in a class? So I guess it's really, like I said, it's mostly an observation about using persistence as the primary justification, which I don't think you should do, making these stronger arguments in other ways, but then also kind of think through in this particular case of what are the unforeseen consequences of saying that you're going to regulate non-toxic things as in part of a class.
There. Thank you, Helen. I've got Meg and Julie.
Thanks. I have just a very quick point associated with Helen's issue about persistence. And perhaps one of the helpful kind of additions to that you could make is the difference between persistence because it's inorganic versus a persistent organic compound. And so, this is something that Green Screen has really started to parse, and its newest guidance has developed a lot of guidance around inorganics, because you can't distinguish among inorganics when you just look at persistence. And so that may be a helpful resource, and just making sure that you're characterizing persistent organic compounds. I think I had some other idea, but I can't remember what it was.
So it looks like Julie was going to make the same comment. And Ken, are you looking to weigh in now?
What I'm struggling with is because I'm sort of where Helen is, the persistence doesn't feel strong enough. But I'm trying to think of another kind of an argument, and I haven't got it very clear in my mind, but let me try to sketch it out. And that is, the department wants to look at perfluorinated compounds in carpets, and there's thousands of possible. Well, there's thousands of perfluorinated compounds, many of which could be in carpets. The purpose of the program, the purpose of Safer Consumer Product, is to help firms look for safer alternatives. And it is a finding of the department that tweaking perfluorinated compounds a little bit this way or that is likely not to produce anything safer, that it looks like there's enough similarity amongst the chemicals that to say that calling out this product and asking for firms to identify safer alternatives, if they just stayed within the family of carbon fluorine compounds, they would not get to safer. Therefore, the department believes that the only way to encourage alternatives is to say, we want you to look outside. You need to identify safer alternatives outside that are not going to all conflate down to being the very same chemical, or at least no different. And it's something along that line, which would get an argument as to why we should be looking outside. I don't know, I don't have it, but something like that might begin to work.
All right. Thank you, Ken. I'm going to use the chair's prerogative to weigh in here with my own comments right now. I'm not a perfluorinated chemical expert, but I have done environmental chemistry for the last several decades, and I've seen so many examples like this. My particular experience is with the term persistence. A lot of chemicals I've worked on have been classed as persistent, but really in the full environment through the full cycle of that chemicals, particularly end of life after use period, it winds up breaking down. But the degradates are also persistent here. So this has been a big theme in pesticide chemistry because there was so much emphasis on persistence. The latest generation of pesticides that have been coming into the market, the parent chemical is not very persistent, but it's often the degradates that are environmentally problematic, and the degradates are persistent. So we see this, for example, for fipronil. It degrades into several fairly persistent and also somewhat even more toxic in some cases degradates that Dr. Sutton and I and others have studied. But that's a great example where the degradate is also problematic and maybe more so. And I think when you think about persistence in the sense of the full life cycle of the chemical, it actually is more important than you would think about the persistence of the individual chemical. So that to me is a really important distinction between persistence of even organic chemicals and in this situation persistence where we're looking at something that degrades into something persistent and maybe gets to be more toxic and so forth. And we're thinking decades and centuries that these chemicals don't go away that quickly, but the degradation process starts. Half-life means half of it is already degraded by the time you get to the half-life. And that's something we also forget because we think, oh, it's all there until the half-life. Well, that's not how it works. It starts degrading today, tomorrow, the next day, there's already some there. So that's, I think, one thing to consider, how you describe persistence, how you characterize that over the family. I do think it would be very helpful to, again, have some kind of visual sort of conceptual model or something that helps explain the full life cycle thinking about this. So that's actually why I asked the questions at the beginning, to make sure, I think you did tell that story in the profile that these impurities appear, that degradation occurs and so forth, but to better visually explain that and show that linkage among all the chemicals in the family is, I think, a really important piece of that. So I like the figure, but a lot of people grasp that more visually, and that's part of why conceptual models are useful. And overall, I'd say that this approach fits with the intent of SCP, so the law, the regulations, very much where we're headed. I would encourage you, in addition to thinking about use of the class here, I don't think that the use of the class here is not justified. In fact, I think it is justified, but based on the overall picture of science and chemistry. But I'd also encourage you to consider, does the department have the authority to demand that alternatives be provided outside a chemical grouping or class when it's requiring AAs? And I don't know if it does or doesn't under the regs, but by listing the class, you're demanding alternatives be provided outside of the class. Is it necessary to list the class to demand alternatives be outside the class? I don't know the answer to that. It's a little bit of food for thought, and I see Meg here and Tim.
Thanks. But one thing I just wanted to kind of remind myself and all of us is that the class has been listed by Biomonitoring California as a class and defined as a class by them. And so that's how the capacity to do that was conferred on the SCP program. And so it's helpful. I'm remembering that partly just because in thinking, like the panel is right to be thinking about, well, what does this precedent mean for other potential classes, and are you getting into trouble with that? There is this sort of check that the candidate list is defined by 23 authoritative lists, and if something isn't defined as a class by one of those lists, I think it would be very hard for the department to define it as a class on their own. So we would kind of have that automatic check on the process, which seems helpful to me. And the one other thing that I wanted to mention was that I remembered what I was going to say also in Helen's issue about persistence, which is that under REACH, the substances of very high concern includes VPVB, right? So substances that are very persistent and very bioaccumulative, irrespective of toxicity. And I think it's a very relevant category to remember in this, although we have a lot of toxicity data about some of the compounds. It's not that anybody in this, in the department is concluding that some of the members of the class are not toxic, but that that they're data poor, but that there's this precedent for considering VPV chemicals even in the absence of complete toxicological information in a regulatory setting. And you might draw on some of that, if that's helpful.
All right, thank you, Meg. I've got Tim, Ann.
Thanks. Obviously, I'm not a scientist, so I don't have much to say about that aspect of it, but I was struck by the conversation. It felt a little bit like the conversations were in some way talking about the concept of using grouping or classes in the program, and then part of it kind of strategizing about this particular proposal and how best to respond to this or frame it. And I'd like to, I think it's probably better not to like look at this particular one and try to strategize about it, but to draw a lesson about what you get from here. So it gets me to thinking about a few things. One, I mean, on that persistence argument, I think you have to go back to the regulations and think about, we're in this prioritization world where it says to think about all of the different aspects of it. So I think it should be the rare instance where you try and do prioritization just on one aspect of it. And to the extent, I mean, to the extent that toxicity is there, it certainly should play an important role in your analysis. And I felt just from what I read, like from the presentation and what I read in the summary, and then I skimmed through the larger report, it felt to me like more time could be spent on thinking about the toxicity, not trying to establish toxicity of 3,000 different chemicals, but thinking about what the level of focus on toxicity should be when you're dealing with a very large class and there's certain similarities across that class. So I felt like more could have been done to talk about, from a toxicity standpoint, why you're worried about this as a class. And I felt from the presentation that a lot of the focus was on the persistence, and I feel I felt like that is it left me feeling incomplete about the analysis. And obviously I'm speaking as a layperson, right? But that got me thinking, so why do you use it? Why is there using grouping? There were two themes running through it. One was there's 3,000 chemicals. We can't go through and look at all of them. Therefore, we have to draw some general conclusions, which I think of as kind of an administrative kind of thought. And the other, which is, I don't mean to, that's not dismissing it. I think it's very valid, right? That you have to make decisions and there's enough of a reason to worry about as a class. The other reason would be you're grouping them together because you actually, you see particular structures, aspects of these chemicals that make you think they're all going to act the same way, which is not, we're trying to save administrative resources by not looking at 3,000 things. We don't really feel the need to look at them because we're convinced by what we know about them that would not be a useful use, right? So there's these two different ways of thinking about why you're doing grouping. If the reason you're doing it is for administrative purposes, it strikes me that it would be good to develop a policy that when you propose something as a group and somebody comes in focusing on one of those 3,000, that you have kind of a standard way of dealing with that now that means you will focus some resources in trying to dig down on both the persistence, toxicity, and the availability of alternatives, because what that means is you don't expect we're going to get 3,000 people coming in. Now we've only got one or two. Now we can really use our resources well and dig into this and do a really good job on thinking about it. So that's it. And on the scientific part of it, I already said what I had to say about it, which is, as a general matter, you might want to look and see what are there ways to improve kind of the technical documents to really articulate in more concrete and accessible terms why it is you're worried about it for toxicity as well as persistence. I think the worry I have about some of this stuff is that when you get outside of the people who really know the material, like folks here, it's harder to convince people to make judgments on a whole group. And that's why I think, the document serves an education and outreach and explanatory focus to lots of stakeholders and audiences who will be looking at this question down the line. So I think it would be useful to kind of think about all of those audiences when you're drafting these documents.
Can I ask a clarifying question?
Sure. Meredith is going to break in, and then Ann.
Just, again, I'm trying to clarify, did you read the full profile, or did you read the reduced version that was in your package?
I read the reduced version, and then I went in and, went through and read particular parts of it.
Okay, thank
right?
you.
But, so I'll tell you what, I don't want to get into all the details of what I thought when I read it, because I don't think it's useful to kind of talk about this particular case.
I got it. Thank you.
And Ann, and if anybody else wants to speak before lunch, throw up your card now.
Grow up. Thank you, Tim. That was really helpful reflection, and thanks for pulling us out of this particular example. So I'm going to keep talking about this example because I think there are a couple of things we can extrapolate. So there's two aspects here. So I think what we're falling into is that the chemistry of other members of this class that are being used in other applications or potentially substituted, it's not well characterized. And as scientists, we're not comfortable talking about chemistry that's not well characterized. And so we're not talking about it, to Tim's point. And the other, but I guess I would echo something that Meg mentioned, which is sort of the precautionary approach of this. Let's call it what it is. That the emerging science on some of the other things that are starting to be studied beyond PFOS and PFOA, it's really troubling. Those endpoints are very, very troubling. But we don't have enough to draw conclusive evidence to say that, this class or subclass of PFAS cause X, Y, and Z. So I think I just wanted to point out that we do have a tendency as scientists to not discuss concerns when they're just emerging, but that's key when we're talking about a precautionary approach. So I think that's something that we can extrapolate into future arguments about classes of chemicals. There's another piece here that I talked about in a recent webinar on PFAS use in food serviceware, which is the aggregate exposure concern. And I'm not quite sure how to capture that, and maybe it is captured. It's been a while since I read the fatter document.
You talk a bit about it in the profile.
You do talk about it in the profile, yeah. So that's something else to think about. How do we want to talk about aggregate exposures when we are required by regulation to look at a specific product and chemical of concern? And I don't really have a good answer for that, but just want to put it there.
Thank you, Ann. Becky, looks like you're our last speaker before lunch.
Just real quickly, wanted to respond to Tim's comment about the different reasons for developing classes, and one of them, I think the second one being knowledge about the toxicity and acting similar function in organisms. And at this point, our information and our understanding is still developing, but I think we do have kind of a weight of the evidence at this point that these chemicals generally have problems. Some might be higher in potency, some might be a little lower, but I think there's already a number of publications, some of them with lots of authors and lots of co-signers, saying we need to be a lot more cautious about this chemical class, the whole class. So I'm sure some of that's in the larger document that I did not reread. But I think we have that evidence developing in the scientific literature, so that is another support toward this larger class-based approach. And then also wanted to echo Ann's comments about the aggregate exposure, the mixture toxicity, something that we're still in our infancy in figuring out how to even do science on mixture toxicity, but we are being exposed to all of these chemicals in aggregate. So acknowledging that as you have in the profile is important.
Wow, it's exactly noon, and I want to thank the staff and the panel for moving very quickly through some really meaty topics this morning. We've got a little wrap up on the earlier topic that we'll catch up at the end of the day. We have an hour for lunch, and I think the panelists will be eating upstairs, and so I need to remind you that the Bagley-Keene restrictions on our conversations outside of the room, so please refrain from discussing agenda topics outside of the meeting. And we will reconvene at 1 o'clock promptly because we've got a full and exciting afternoon. See you then.
Balku, will somebody be here to? Yes, you can leave your stuff here. Yeah.